sorry, right, okay, if I repeat it here, if you have a how to, just the question is how do we verify, just the topic what we are doing here is the partial fraction involvement of integration. If there's a fraction over here, initially see whether the differentiation of the denominator is available in the numerator. If it is so, not a problem. You can use, if this differentiation is here, so you can form into this formula and you can get this answer. It's not a problem. But if you have a question somewhere like this, here, the differentiation of, if you just expand this to x squared minus 2x plus 2, the differentiation is 2x minus 1. You cannot form in the numerator. You cannot form it in the numerator. Okay, in this situation, if there's a fraction where the denominator and numerator are polynomials, and if the differentiation of the denominator cannot form in the numerator, in such situation, we just use the partial fraction, and we can check whether whether we can just go ahead with the partial fraction, because there are different approaches as well. Therefore, first check with the partial fractions. Now let's go ahead with how to do this partial fraction. Just initially, we just simplify this and try to write it as a, sorry, try to write it as a partial fraction. I think we have already learned how to do the partial fraction at the in last sessions. A over x plus 1 plus b over x minus 2, right? Okay, then we can write, I'm writing the steps, not all the steps. Then if you feel like this is hard, just refer our previous topic partial fractions and see whether how it comes. Then you can say, if you put x equals to minus 1, it's minus 6 equals to minus 3a, therefore a become 2. If you put x equals to 2, minus 3 equals to 3b, therefore b become minus 1. Therefore, you can write the integration in this format. Yeah. Therefore, when you're working out with this initially, when you're writing it here, you just write it as I. Therefore, no need of writing it again and again, right? Then you can straightforward, you can write this I in this way. I equals to integration of a is 2 and b is minus 1 over this is x plus 1 and x minus 2. X plus 1 and x minus 2. Okay. Then what you need to understand here is, we can now you can see the differentiation of x plus 1 is available over here, or there's a different approaches. You can say, we know that integration of 1 over ax plus b, the integration of that is how much? That is turned up to 1 over a ln ax plus b. If it is if the power is 1, if it is not, you have to use the power rule. Right. So you can say 2 ln x plus 1 minus 1 ln x minus 2. Plus is the final answer for that. Therefore, you can, if you want, you can simplify like this. X plus 1 squared, I just brought this 2 in, divided by x minus 2, right? Then when you're writing ln, we just put this modulus mark in front here. The reason to write in that way is because we know that the ln values does not exist for negative answers. Just to say it's but if you just put a bracket, even doesn't make a big difference. But usually we use this notation to represent that whatever the what do you call that, ln values does not contain any negative answers. That's a fact of learning that. Okay, now let's go ahead with this to another question here. That is, if you get this kind of it, 8x squared minus 19x plus 1. Yeah, 19x plus 1 divided by 2x plus 1. Then this is x minus 2 squared. Then initially expand this and see whether the differentiation is available here. So obviously, when you happen to see, you don't see the what do you call that, differentiation over here, or by multiplying by just a constant even, you cannot form it, right? Okay. So in this situation, you can see since denominator and numerator both are polynomials, we can check with partial fractions, right? So initially, we'll just try to make it as a partial fraction. I just mark it as I. That is for our convenience, or the ready, what you call, to minimize the time spent of writing the same expression and again and again. Then you can write 8x squared minus 19x plus 1 divided by 2x plus 1 times of x minus 2 squared is equals to a over 2x plus 1 plus b over x minus 2. If you have any doubt about why I'm getting these steps, just please ask. I think you can remember how we did the partial fraction for this. So with that, you can say, if you have any doubts about this, any of this step, please ask, right? Don't just keep quiet. Like that it comes, right? Okay. Then what you need to do is initially try to find out the value for c by just making x equals to 2. If I make a 2 here, 18 to 4. 18 to 4 is 32. 32 minus that is minus 4. Minus 4 plus 1. It's minus 3. I think it's correct. These two terms get cancels. 4 plus 1 is 3c. Sorry. 2 4 plus 1 is 5. Let me see if it's correct. If I put 2 here, 2 into 2 is 4, 4 into 8 is 30, 32. Just 19 into 2 minus 38 plus 1 is equals to, both the terms get cancelled, 4, 5, 6. 5, 6, it's turned up to then, yeah, that's correct. Minus 32, it's minus 6. Yes, it's minus 6. Minus 6 plus 1 is minus 5. It's 5c. Therefore, c is equals to minus 1. Then if you need to find the answer for, we'll try to make it by x equals to half. If I make x equals to half, you can cancel these two terms. Therefore, 8 into 4, it's turned up to 2 minus 19 over 2 plus 1 equals to half. Okay. Is equals to, if I put half here, which term, these two terms get cancels. Half minus 2 is half. Minus 2 is 3 over 2. It's 9 over 4. 9 over 4a. There with that, you can get the answer a. Become 2 plus 1 is 3. Yeah. So if you operate these ones, you have to go with the perfect figures. 2 minus turn to minus 13 over 2. There is a problem over here. Just for this case, if you put half 8, so we put half minus 19 over 2. It's 19 over 2. Minus 19 into half. 13 over 2. It's correct. To the other side, if you just replace it, if you put half, half minus 2 is minus 3 over 2. Yeah. Let's see the questions. Whether the question is correct. Yeah. Then what you can get here is just see some kind of a problem over here. It's half minus 1 is 2, 2 raised to 9 over. What's 13 over 2? Knock it out. I'll tell you the thing. Yes. 8x squared minus 19x. 8x squared minus 19x plus 1 and yeah. So I think I made a mistake somewhere over here. Ah, yeah, here also only the problem with it. So just wait, I'll just do the correction over here. So you have to put not plus half, it should be x equals to minus half. Minus half, then you can say 8. Then 10 down 18 to minus half squared is turn up to 2 minus 19 over 2 into half is plus 19 over 2 plus 1 is equals to, for all of these facts get cancels, it's turned up to minus half minus 5 over 2, it's 25 over 4a is equals to here also 3, it's 6. 25 over 4 equals to 25 over 4a. You just check with this calculation, but I think it's correct. Therefore, a is equals to 1. Right. Now, all the substitutions are closed. Therefore, I just put x equals to 0. You'll be very carefully do this because if you make a small mistake even, it makes a lot of confusion. It's kind of hard to understand it. 0 plus 1. If you put 0 here and if you put 0 here, you get the answer 4a. And if you put a 0 here, it's turn up to minus 2b. If you put a 0 here, it's plus c. So with these facts, you can say 1 is equals to, we know the value for a is 4, it's minus 2b. I think 2b we already didn't get it. Minus c is minus 1. Right. So from here you can say, if you get 2b here, 2b is equals to 4 minus 1 is 3. 3 minus 1 is 2. Therefore, b become 1, obviously, right? Okay. Then what you can get here is that then we can find the partial fractions, the partial fraction formats. So you can write I equals to integration of 1 over 2x plus 1 and b is 1 over over here what you get here is x minus 2 and minus 1 over x minus 2 square. That's a factor to understand, right? Okay. Now let's go ahead with this. Over here, you can use the ln integration because here the power is 1. Here also not a problem. It's not a doubt with that. You can say ln. This is according to this relationship. We know that integration of 1 over ax plus b, not with power 1 only. Answer is 1 over a ln ax plus b is the answer. Therefore, you can say 1 over 2 ln 2x plus 1 plus ln x minus 2. And here, for this question, you cannot do ln because for this part, it's kind of different. make it because if the power is 2 allowed, you cannot use ln. So you have to use this formula for that. X minus 2 to the power minus 2. Then only you can do it. That means the approach for this one would be integration of ax plus b to the power n integration. Because if a power is 1 only, we can use the ln what do you call ln approximation. So over here you can say, if you integrate it, you get the answer 1 over ax plus b to the power n plus 1 over n plus 1. It's different. Then this integration turn up to x minus 2 to the power minus 1 over minus 1 and 1 over a. No need to put it because his a is 1. Therefore, you just put this value over here. So this integration goes from minus 1 over x minus 2 minus 1 over x minus 2 plus c. So if you want, you can simplify this one in this format. You can write ln square root of 2x plus 1 if you brought half in as a power into x minus 2 minus 1 over x minus 2 plus c would be the final answer for this. That's a way of getting this answer. You just check whether is there any calculation error or something available. Other than that, you can just get it with it. Right. Okay, first check whether is there any calculation errors. Other than that, the technique is the same way. Right, when you do it, you have to be very carefully do it. And today I don't have my calculator, so it's kind of we have to do it everything manually. There's a lot of chance to make a lot of errors. And if you happen to see a question like this, if it is 2 over 1 minus x squared, 1 minus x squared. For this kind of situation, even you can say here over this question, it's the differentiation of denominator you cannot available in the numerator, and you can then you have to go ahead with the partial fraction. So this is 1 plus x and 1 minus x. Okay, then what you need to do is dx. Then you can use a partial fraction. 2 over 1 plus x into 1 minus x, you can write a over 1 plus x plus b over 1 minus x. Therefore, 2 equals to a times of 1 minus x plus b over 1 plus x. So with that, if I put x equals to plus 1, 2 equals to, this is get cancels, and 2b, therefore b become 1. And if I put x equals to minus 1, then 2 is equals to, this is get cancels, minus 2, 2a, therefore a become 1. So with that, you can say this integration is 1 over 1 plus x plus 1 over 1 minus x. Ln 1 plus x plus minus 1 times of ln 1 minus x. So this is ln 1 plus x minus ln 1 minus x. With that, you can say this is ln 1 plus x over 1 minus x. So you can put a modulus mark to say it's a, what do you call that? It does not make into negative. That's a way of simple way of doing it. I'll do a little bit of a advancement for this question. If it is a question somewhere like this, just 1 second. Yeah, if it is a question like this, integration of 9x squared minus 3x plus 2 divided by 9x squared minus 4. For this kind of situation, initially what you can understand, it's a polynomials, and if the differentiation is not available, therefore we have to go ahead with the partial fraction, right? For in this case, you can see the power of the numerator is same power as this much. If the power of the numerator is equal or greater than the power of the denominator, initially we have to go ahead with the long division before you go for the partial fraction. Therefore, you have to divide so you can say it's 9x squared minus 4. If you subtract it, you get 0 minus 3x plus 6 pute. Then there is nothing further than that. Therefore, this integration turn up into 1 plus minus 3x plus 6 over this bit. Make a just then you can make it into factors and do it with it. 3x minus 2. Right? Then you can go ahead with the partial fraction for this. So you can write minus 3x plus 6 over 3x plus 2. 3x minus 2 is equals to a times of 3x plus 2 plus b times of 3x minus 2. Then you can write minus 3x plus 6 is equals to a times of 3x minus 2 plus b times of 3x plus 2. So with that, if you make the fraction x equals to minus 2 over 3, then you can say if it is minus 2 over 3, these terms get cancelled. So over here, if I put minus 2 over 3, it's turned out to 2 plus 6 is 8 is equals to, if I put minus 2 over 3, it's turned up to minus 4a. Therefore, a become minus 2, right? Then if I put x equals to 2 over 3, put the 2 over 3, what happened? This term get cancels, then it's 2 over 3 become minus 2 plus 6 is plus 4. Then yes. Then 4, and this is turned up to, if I put this plus 2 over 3, it's 2 plus 2 is 4b. Therefore, b become 1. So you can write this integration I. And you have to be a little bit careful. There's a 1 at the beginning. It's not a, you have to include that one as well. 1 plus 1 over 3x minus 2 minus 2 over 3x plus 2. That's a way of getting this answer. Yeah, right. Then you can do the usual integration. So you can write this is 1 integration is x plus here it's 1 over 3 ln 3x minus 2 minus 2 times of here it's 1 over 3 ln 3x plus 2, right? Okay. Then plus c, you can write the plus c at the end. Then you can write this is x plus, if you want you can take it in and write it, or you can just write 3x minus 2 minus 2 over 3 ln 3x plus 2 plus c is the answer for that. That's a way of doing this question.
Sir,
Yes, yeah, what is it? Yes, can you
can you explain how you divided that?
Here,
Like how we got minus 3x plus 6 over 3x plus 2 into 3x minus 2?
which one? What is it? What is it? This one then? Oh, the
How we
front one.
divided the first part, like no,
With another.
up, sir, like
One second. One second.